Hello, everybody. Welcome to this edition of ExoLife Hangouts. My name is Tony Darnell from deepastronomy.space, and I've got another really great hangout planned for you guys tonight. We are going to be talking about some work that's being done by a group of people, in particular our guest, who has written some papers and has been thinking about the Drake equation. Now, one of the fallouts of all of this really great stuff of being in the golden age of astronomy, like I always tell you about, is that we now know that there are more planets in our Milky Way galaxy than there are stars. Well, that has a lot of implications, and the first place we turn to make little tweaks is the Drake equation, and we'll talk about that. But our guests today have written some papers and has been thinking about, well, wait a minute, Let's not talk so much about the number of civilizations out there as much as can there be one at all, and what's the probability of that? And he's done a lot of really great thinking about this, and we're going to get his thoughts as we get going. These hangouts, though, I want to remind you, are a collaboration between the Planets Foundation and deepastronomy.space. The Planets Foundation is doing a lot of really great work on helping us get telescopes built on the ground that might help us find life. And at the top of these hangouts, I'd like to get Svetlana to give you guys a little bit of a briefing on what you guys are doing. Do you guys who wants to talk, Jeff or Svetlana?
Go ahead.
Just give us an idea of what the Planets Foundation is doing.
Well, Planets Foundation looking for life on other planets. That's what our ultimate goal. And for that, we develop techniques and we develop technologies. And our primary goal, first step, is to build big telescopes and unconventional big telescopes, bigger than anything what is being planned now, like 65 plus meters. And with this telescope, we will be able to have a census of extraterrestrial civilizations in the solar neighborhood within 20 light years, and that census will be complete. For the first time, it will be complete, and this is our goal.
Great. And so I would invite you guys to go and check out their website, planets.life, and they've got a lot of really great things going and coming down the pike to help you get more involved in what they're doing, as well as they have some fundraisers and things like that coming up. So check them out at planets.life, because I think what they're doing is very, very important. Okay, so got a couple things here. I'm broadcasting on a lot of different stuffs. I've got the usual candidates: YouTube, Twitch, Facebook, and what else am I? Oh, that's right, Periscope. I've got the live chat coming, and already you guys are showing up. I see Galaxy is there, and Cosmic Stardust. Welcome, guys. John Newman's around. That's good.
Hello,
to see you
guys. You're always there. Thank you for coming.
That's right. Thank you very much. As well as Care Bear and others. Joe Schmo was even here. I mean, you know
it's a party.
You made it when Joe Schmo has made it into your live chat. So I can just die a happy man right now. Okay, let me introduce my guest before I get too far along here. He is, let me get to the right view. My guest today is Dr. Adam Frank. He is a professor of physics and astronomy at the University of Rochester at New York. He is also a contributor to NPR and the New York Times. He's got a blog, don't you, Adam, on
Yes.
NPR that you write about quite a bit as well. So while we get going on this hangout, folks, I want to let you guys know I put a link to the press release from the University of Rochester in the description box. There's also a link to the paper that we're going to be discussing as well. So, okay. So I just want to let me go ahead and get started here, and let me just ask you, Adam. The title of your paper is a new empirical constraint on the prevalence of technological species in the universe. And the press releases basically gave us a nice little synopsis of what you did, saying that it is setting some limits to our uniqueness. Why don't you give us a summary or an introduction into what this is all about?
Okay, so people are probably familiar with the Drake equation, which was developed in 1962 or 1961, I believe it was the meeting that Frank Drake wrote out the equation where he was trying to figure out how many civilizations that exist now that there might be radio contact possible with. And that has become sort of the standard framing device for asking questions, astrobiological questions, particularly those about exocivilizations. And what we realized, so that equation has 7 terms. The first one is the number of stars in the galaxy, or the rate of star formation. Second one is the fraction of those stars that have planets. The third is the number of planets in the habitable zone around each one of those stars that have planets. And so those are the first three terms. They're all about astronomy. The next three terms are the fraction of planets that develop life, then the fraction of the planets where life is formed, where the life becomes intelligent, and then the third term is the fraction that develop civilizations. And then finally, the last term, the very important term, the final factor, is the average lifetime of those. And so what, now the whole history of thinking about this is trying to nail down each one of those terms. And what Woody and I realized was that the first three terms now, and this is remarkable when you look at the history, the first three terms, the astronomical terms, have all been nailed down. That is the fruit of the exoplanet revolution, right? We now know that every star in the sky has planets around it, and that approximately 1 in 5 of those stars has a planet in the habitable zone, in the right place for life to form. And so Woody and I were thinking I will explain later how this was actually, we weren't doing this in isolation. There's a project we're working on in terms of thinking about Earth and climate change and our future in this astrobiological context. So that's where this paper comes from. We can talk about that later. But what Woody and I realized was wow, this ought to be worth something, right? All this new knowledge we have ought to be worth something in terms of figuring out something about the real question we're interested in, which is, are we alone, right? Are we not only alone, but another way to phrase it, are we the first? Are we the first and only time that the universe has generated a technological civilization? So what we realized was by reframing the Drake equation, by thinking about it differently, we could actually set, for the first time, an empirical limit, a limit that was based on numbers, on the all-important idea of probability. What is the probability per habitable zone planet that you're going to get a civilization, right? So that's the thing we're interested in. What is the probability? If I give you a bag of habitable zone planets, how many do you have to pull out before you end up with one that actually has an exo-civilization, right? And so what we were able to do by playing with the equation, and we'll talk about exactly what we did, but we were able to set an empirical limit on how low that probability has to be in order for us to be the only time that in the entire course of cosmic history that a civilization has been created. And that number turns out to be 1 in 10 billion trillion, right? So you'd have to sort through a bag, for us to be alone, for us to be the only time it's ever happened, you'd have to have a bag of 10 billion trillion habitable zone planets and have none of them have a civilization.
Okay, so let me just stop you there, folks. That's a big number. And before this hangout, I went through the internet, and I just went through a couple of chances of things happening of our own. So your chances of winning the lottery are 1 in 14 million. Your chance of getting hit by lightning this year is 1 in 960,000. It reduces down to 1 in 12,000 over your entire lifetime. Your chances of getting hit by a car in the United States is 1 in 4,292. And your chance of getting killed is 1 in 47,000. Your chance, I like this one. Your chance of getting pregnant while on the pill is 1 in 1,000.
Unless you're moved.
Yeah, that's terrible, isn't it?
I said, what are the odds of becoming the president of the United States? Well, there's 300 million Americans, 1 in 300. But the chances for a random American to become president of the United States was 1 in 30 million, because we see an average of 10 presidents in our lifetime. Being born with 11 fingers or toes is 1 in 500. Your chance of dying in a plane crash is 1 in 9,700, and becoming a billionaire. And this is where Dr. Frank's work is coming in very handy. The internet said your chance of becoming a billionaire is basically 0 or 1 in what's that number again?
1 in 10 billion trillion.
Right, 1 in 10 billion trillion, because there are 1,426 billionaires on the planet Earth among 7 billion people. So there you go, folks. There's some context.
Wow, that's impressive.
So,
what about chances to be bitten by a shark? I'm afraid of that.
Oh, yeah.
In the state of Florida where I live, that's actually pretty non-trivial. That's actually a good thing about here. So, okay, that number was, remind us again, that was the chances of, for us to be the only one, that's how hard it must be for a civilization to...
Well, so, no, let's be, because this is where you gotta, where the subtlety comes in.
Yeah, I need to...
So nature, right? Nature's, there's zillions of planets out there. Stuff is happening on those planets. There's, biological evolution, sociology, blah, blah. We don't know what the actual probability is, right? We have no way of knowing what the actual probability is. Nature has determined that. And if we had like spaceships and we could go travel around, we could go figure that out. But what we did is we said, look, here's the limit. If nature's, choice for that number is less than, we call it the pessimism line. If it's less than the pessimism line, then we are the only time it's ever happened. If it's greater than the pessimism line, then we're not the first. This has happened before.
But it doesn't say anything about how common it is, just that somewhere in the universe, and that's important we talk about this, you're not talking about the galaxy. You're talking about somewhere.
We're talking about all cosmic space and time, right? The entire history of the universe. That's why, our result doesn't say there's aliens out there, visiting us. Our result could be absolutely, when I say, again, we have to be careful what we're saying. What we're doing is we're placing a limit on the probability. So even if the probability was, say, 1,000 times bigger than that, our galaxy would probably still be empty right now. What we're saying is that so here's another way of phrasing it. Unless nature is perversely biased against evolving civilizations, right? Unless that's true, then it's happened before, right? And, given that number is so small, nature could have a pretty small number for its actual we call it the biotechnical probability. That probability could still be pretty small, and there would still be millions, trillions, of civilizations that have come before us.
Well, this is sounding really optimistic. So I want to put the Drake equation picture that I took from your press release from the University of Rochester, and at the top, we already had it up while you were talking about the Drake equation the first time. This is just a whole bunch of fractions that are being multiplied together. It's a pretty simple concept, really. But at the bottom is your new formulation. You've said basically the first three terms have been, we've found that out.
We know what those first three terms are.
Right. And they're on average in our galaxy at least 1.6 planets around every star. That we learned from Kepler, among other places. So so tell us about this bottom part here. It says A equals NAST times FBT. What are those terms?
Okay, so what we did is we took the Drake equation. First of all, one important thing was we got rid of the lifetime. We're not interested in how long they last, right? And what that means is most of the civilizations we're going to be talking about here, depending on that lifetime, are long gone, right? And so, actually, and this is the most important question in some sense, how long do they last, right? And that's the question for us, because we want to know how long we're going to last. But we took that number out, and by taking it out, we could then formulate this biotechnical probability. So the first term, we call it the archaeological form, because in some sense we are talking theoretically about the archaeology of civilizations, because most of these civilizations will be gone unless L is very large. So we combined all the astronomy terms into one term. That's the first one, on the right-hand side of the equal sign. And then we combined all of the life terms, the biology, sociology, evolution, into one term as well. And then we could, because we had, all the life terms in one probability, that's what we call the biotechnical probability, we could set a limit on that biotechnical probability. And that's where the pessimism line, as we call it, is 1 in 10 billion trillion. And really what it is, it's just 1 over the total number in the universe of habitable zone planets. It's a frequency. You ask, if I have a box with 10 balls in it and one of them is white, I have a 1 in 10 possibility of pulling out a white ball. So it's very simple. There's no magic here or anything. But it's just a formulation of it that allows you to set this actual empirical limit on the the bio. And so here's another thing that's important to understand, right? The whole discussion about exo-civilizations has, since Drake, been one of pessimism on one side versus optimism on the other, right? Now, of course, optimism is to say that every habitable zone planet gets a civilization, right? That you set all those probabilities equal to 1. But what is pessimism, right? Is pessimism 1 in 1,000, 1 in a million, 1 in a billion? If you look at the history of this debate, what you find is the people who were pessimists, like Ernst Mayr and Brandon Carter, their numbers that they came up with, which they said, oh, look, here, I did a number, and it's really small, therefore, there's no other civilizations. Our pessimism value is way smaller than theirs. So if they were right, there'd still be millions, or billions of civilizations that have occurred in over cosmic history.
So you're more pessimistic than the most pessimistic that has
been. Well, the limit that we put on is so much lower than what people who thought they were pessimists, what it says is that they were actually optimists. They thought they were being pessimists, but this, the new data shows that if their estimation was right, then there will have been millions or billions of civilizations that have occurred over cosmic history.
Okay, Jeff and Svetlana, I know you got some comments on this.
So the point is that we now know that there's so many potential worlds. I mean, that's really the point. There are just so many potential worlds.
Right.
That multiplier means that the frequency has to be incredibly low. And I think if you're a believer that we're the only intelligent species in the universe, you're on the retreat.
Right.
I mean, it's...
No, you're not. I'm sorry, but you're not. This says nothing about 1 over the number of habitable planets in the universe. Says nothing about how difficult or easy life is, and that's going to have. You can have all the habitable planets you want, and none of them are going to have any life in them.
Well, that's true.
Life is hard.
That's true, but you have to believe in all of these exceedingly rare possibilities, and I think Adam's point is that he put a number to it, and the number is really tiny. I mean, it's not the same as the number of protons in the universe, but it's a number which is, as physicists, we start to think that there's something to be learned when the numbers that describe events become exceedingly large or exceedingly small. And his number, depending on whether it's 1 over it or the number, is in that regime where you kind of have to believe in. I agree with you, Tony. It's possible that life is exceedingly rare. Now, remember the argument in one of our earlier Hangouts was that, well, okay, so part of the reason why some people believe it's so rare is because there's a sequence of almost impossible things, at least from our perception, that has to happen to create us where we are. But the truth is that all of those impossible things have happened, and each one of them, if you took as an independent event, you might say, well, it's almost impossible that we could have cyanobacteria, right? Because the steps that take us from the RNA world to the DNA world are exceedingly rare. But actually, isn't it that we're just quantifying our uncertainties, what we don't understand? And it's that same, in my mind, it's that same principle throughout astronomy that put us at the center of the solar system, or the center of the galaxy, or the center of the universe. And every time we think that we're unusual, or that chances conspired to put us in this very unique position, we were wrong. So I find some comfort in Adam's number. I think that he's quantifying in some ways what tells us that we really don't understand all of the steps that lead to life. And there's 7 or 8 miracles that have to happen to get us where we are, right? And you could say, well, because it's 7 or 8 of them, it's exceedingly rare, and therefore we're the only ones. But you might have said, well, any one of those miracles was so rare that we shouldn't have gotten to where we are. And that just tells me that we have a lot to learn about some of the circumstances that led to what we are. So I
think that what you talk about miracles, for us to come here, we have these particular 7 miracles. But for the life to come somewhere else, it's some other miracles, and they happen all the time. Meteorite hits the planets, and etc. Yeah, and supernova explosion erased the life until almost the last bacteria. But the last one survives. It continued dividing, and the new chain of evolution starts. So I think all these miracles happened all the time. So it's not necessarily we say, oh, it's rare. But I'd like also to point out that you said you excluded lifetime of civilizations, but there were other attempts to include it, yeah, and estimate how much it is in principle. And everybody concluded there could be so many civilizations before us, because otherwise you have to assume so long lifetime of this civilization to have a few. It feels impossible. Or yes, then we should see consequences of these mega civilizations existing so long. And okay, we don't say it. Maybe we are not members of the club yet. But so I think it's like, whether you look at this way or that way, it's always like come to the conclusions that there could be so many before us. But maybe we're just alone right now in this point of time and space, because lifetime is not so long, and that's lifetime is so interesting to learn. Yeah.
Right. Can I just jump in here for about this one particular
Absolutely
point?
Not. This has nothing to do with you. We're talking about. Please.
So this idea of the miracles, right? There's Brandon Carter in particular is the one who originated what's called the hard step model. Right, and he formulated. It was a brilliant argument. It was this incredibly brilliant argument that allowed a mathematical formulation and a number to be calculated. And so he came up with this idea that there are a number of very difficult steps that life has to pass through in order to get to a civilization. Right, and so in his first paper, he, I think he said there was 10. He conjectured, based on he had some arguments for why there were so many. And the number of, or the improbability of a civilization goes up with the number of steps. But even with his 10, he ended up with a number which he said shows that there's no other civilizations, and it was 100 times higher than the pessimism line, which meant if he was right, there were 100 civilizations that already occurred. Now, since then, Watson and some other people have relooked at the hard step model, and they've concluded there's only 5 hard steps, in which case the number you get is 10 to the minus 10. In other words, if they're right with their miracles, oh my God, there are these miracles that have to occur, there still will have been 11 orders of magnitude, which is 10 or 100 billion? Yes, that's 100 billion. There would still have been 100, even if they're right with all their thing about the miracles, there was 100 billion civilizations before us, right? So
that's like how many stars in the galaxy. That's the same number of the stars of the galaxy.
Right. So that's what I'm pointing out, is that there's a history to this debate. And in this history, you find people who came up with arguments for pessimism turn out now that we have a number, that we can set the line, the limit, those people actually turn out to be optimists. And that's the important point.
Yeah, I actually want to come back to this club idea. I was thinking that, there could be still lots of civilizations out there, we just don't see them. And I was thinking in the direction that, we know that speed of light is limited for us, for the universe we see. Well, I don't know, I don't want to be completely unphysical and esoteric, but imagine that others figured out how to be beyond that limit.
Okay, you're out of bounds. You are out of bounds.
We are not members of that club yet. Come on. We just didn't figure it out. And once we figure it out, we will see amazing amount of civilizations out there beyond the speed of light.
Okay, that's.
Well, it's certainly. I mean, there is without breaking the speed of light. There's certainly the argument that what a civilization presents to the universe, if it's a much more advanced civilization, if they're using Z-rays to communicate, and not radio or something, they're visible to us. So, But again, I think it's entirely possible that the galaxy is empty now, right? Because it's all about that lifetime. If the average lifetime of a civilization is 1,000 years, it can be happening pretty frequently, but nobody lasts very long. And of course, this is the question for us. We're facing climate change and the crisis of sustainability, and that may very well be a kind of great filter. I'm sure you guys have talked about it.
Yes,
right?
I knew it.
That may be the great filter. The great filter.
I talk about it all the time.
Yeah, okay.
Well, that's why, so now let me bring this in, right? So, this paper was part of a longer series of work we're doing, which is we're trying to set climate change and sustainability into an astrobiological context. Because if there were trillions of civilizations before us, it's pretty easy to argue that if they were, like us, a energy-intensive civilization, that there's no way of avoiding climate change. There's no way of avoiding feeding back on your planet. It's the second law of thermodynamics, so that you push your planet into a different state than the one you built your civilization in. So, in many ways, what we're going through right now may be a generic sort of phenomena if a planet evolves a technological species.
So what about those hot Jupiters?
So wait, hold on, just 1 minute, okay? So it's true, right, that energy is about life, and it's true that we think of ourselves as being fragile, and it's true that we could very well face existential crises, but the other side of life is it's incredibly robust, and so it may set us back 60 million years, but that's just a blink of the eye.
Life is robust, but humans aren't.
Well, I'm not rooting for humans. I'm rooting for the ecology. Right?
So insects will survive.
Technology and civilizations and bacteria don't really.
It reboots, and the fact is that we could be within 42 years of the singularity, in which case our energy use is just for information technology, and we have a completely different definition of what life is. So there's all kinds of assumptions built into this picture of wet biology, and I think that there's enough data to suggest that evolution naturally leads to something which is tool-like, which leads to technology, which leads to life, which is not wet chemistry.
Well,
this notion that there's a certain lifetime for civilization there's a certain lifetime for the sort of creatures that we are. And that's an incredibly short period of time. It could be that the endpoints always of life are things that have much more to do with free energy and free information and things that we have a hard time visualizing, except for Star Trek. So I'm with you on this idea that maybe there aren't very many civilizations like us, but we did a similar calculation with the Drake equation in this paper that Svetlana sent you, which said that if you're more of an optimist, right, and point out that we're not very special, you can write down an equation that says that if we do a census of 200 or 300 planets and we don't find any life, that tells us something very fundamental about the evolution of life. But it's more likely, if you believe in life not being very unusual, that if you do a census of 100 planets where you have the sensitivity to see the heat signature that you're talking about,
right.
The heat signature of life is almost universal, and if you add up all the energy of our cell phones and our cars and our transportation and everything that we do, we're already using air conditioning. We're already using 0.05% of the total solar energy that strikes the Earth. Right. That all has to be converted into heat somehow, and that means that the astrophysical signature we're finding, say, Los Angeles as it rotates around the field of view of Proxima Centauri is a few parts out of 10,000 signal, which we can almost see. And in fact, with some of the telescopes that this group that we're working with is talking about, we can look for this sort of rotational modulation of the thermal signal of civilization, at least if it's somehow derivative to what we are now. We're not too far into the future. So part of the Drake equation is it parameterizes our assumptions into something that may be misleading, because life could be very different. And I'd rather believe that once life evolves on a planet, it has a success probability that extends into infinity, and the success reflects some of these existential disasters that we worry about, but I don't even think of those necessarily as a disaster unless they completely annihilate all life on the planet, and that's really, really hard to do.
Well, if you look at the numbers that Adam's talking about, it's inevitable that they succeed. I mean, there's just so many possibilities for success that it's a virtual certainty.
And if you allow that there is, as Adam would argue, that there is at least one civilization or a billion civilizations that's come before us, ask how many of them decided that they needed to plant grass around their house, this panspermia idea, and were the grass.
Right.
Well, you see, I'm sorry, I want to say, what we have to care, actually, is that we leave signature of civilization after us. On this planet, because we will be erased, we will disappear as a civilization, there will be other creatures, we don't know if they develop intelligence or not. It would be great to leave a message for them. And, well, somebody maybe left for us, we don't know, we can search, but I am totally, I'd like to have that project to leave a signature for civilizations coming after us on this planet. And this, what we talk also about emergent civilizations, it's not necessarily on different planets. It could be re-emerging on the same planet, within the habitable zone, within these billions of years.
So another way of saying that is it's okay to root for the planet of the apes.
Yes, it's okay. Let's get the
message. Well, let me just say, I mean, so, I think, well, so we wanted to, I'm doing a lot of network theory right now also. And what I think that civilizations, right? I mean, at least, especially, we're very vulnerable now, right? Because of we're a single planet species. Our technology still is, somewhat rudimentary. And I think civilizations are particularly vulnerable, to climate change, to this the kind of thing that we're going through right now. So there's a bottleneck, which I think absolutely we can get through. But I think there's going to be winners and losers, right? That's my message. I do a lot of work about climate change with the public, and part of this perspective for me is so important, is to get people to understand that this has probably happened a lot, and there's going to be cosmic winners and cosmic losers. Planet's going to be fine. No problem. But, technological civilizations are basically stacked networks, right? They are coupled networks of information, energy, transportation. And, an individual network may be robust, but when you couple networks, especially a complex network, a failure can just ripple through them and just tear it apart. So it's really possible that, especially a young civilization, that a climate change could push it into failure. It doesn't mean everybody dies, but you could, if the planet goes to 7 degrees of warming,
you can be set back so many thousands back.
You may never be able to get back, and so you basically, your numbers drop enormously.
Yeah.
And
let me ask you while you're on that, then, where do you think we are as a civilization? Are we young? Are we established? What's your sense based on what you're thinking on this?
I think we're very young. We're very, so there's
and vulnerable then.
Very, very vulnerable. I'm sure there's other existential, dilemmas that are going to come further on, which we can't even imagine. Maybe some of them have to do with the singularity happens. By the way, I'm skeptical of the singularity.
Me too.
Just throwing it out there. Yeah. But I'm sure there are, other ones. Maybe, once you advance a certain point, then the wolves between the stars find you and eat you. Who knows? Maybe everybody's not nice.
As a civilization, we just gain self-conscious. They started to gain that. We just like toddlers, I don't know, a few months, which just start to figure out the world around, and that's possible,
The image I like is we're cosmic teenagers, right?
Mm-hmm.
Is that?
Well, I think it's much younger.
Well, except that we've got, just like a teenager, right? When you're a teenager, you've gotten to the point where you have some power over yourselves. Like in 100,000 years ago, we didn't even matter. But now we have power over ourselves and power over the planet, which is what the Anthropocene is about. So we have keys to the planet, right? And like every teenager, are you going to handle that, or are you going to drive the car or the planet off a cliff? So, it's a very early stage, and because of that, we're not very mature, right? Look at the debate about climate change. People are like, it can't happen, it's a hoax. Part of that is because people don't really get the idea. This probably happens all the time.
I'm attributing a lot of that to education. I blame our education system for that, but that's a different conversation. So even under the more generous definition of a civilization, let's say you include the Egyptians, the Babylonians, go on back. We're maybe 6, 8, maybe if you want to get super generous, 10,000 years old. We probably weren't emitting into space by at all for the last maybe couple hundred years. So I want to ask you about this idea of other things that could get in the way, like every galaxy has a habitable zone. Our galaxy has one. And does the fraction of habitable Earth's term, or habitable planet's term, include all of that? Does it take into account habitable zones of galaxies? Because not a large percentage of each galaxy can be. You can't just say all stars might have these many planets, because not all stars are in a habitable Region of the
No, our term did not take that. And, if you really tried to do, and you can also, if you really want to do this, like, super exact, you would have to integrate over time, right? Because there's a period when there are no planets, right, early on. But we played with that, and it doesn't really shift things very
doesn't
much.
matter much.
So,
okay.
Yeah, you're going to get maybe a factor of 10.
What I love about this is orders of magnitude don't matter. Okay.
No,
even 2 or 3 when you have 24.
So let's knock off a couple billion. Who cares?
So if you're factoring
question about
you got to work with factors of 2. You're in the wrong business,
So about civilizations being wiped out. So we're not just actually. So civilizations on Earth have been wiped out by climate change. On the west coast of Greenland, that culture was wiped out by warming during the medieval warm period. The Mogollon, the Anasazi, the Hohokam were likely wiped out by climate change. But guess what? Civilizations elsewhere at different latitudes or with different levels of technology survived and moved on. And so I'm not advocating that we want to hasten or accelerate climate change on the Earth, but I think that it's life is the most robust, indestructible thing we know about, as long as you accept that we're not rooting for me or you or even the United States. We're rooting for the ecology.
Right.
And maybe it is the apes.
Siberia will survive, no problem.
But I think that we should be aware, and we should do what we can to minimize the impacts. But in fact, that's why technology exists, right? Evolution is a response to external influence, and the competition and survivability is nature's way of somehow overcoming external influence. And the external influence of climate change, which has come before, right? The natural climate change due to the sun or due to other changes in the atmosphere or cloud cover changes or whatever, have taken place, and civilizations have been wiped out. But life didn't get wiped out.
Well, exactly. And that's why when people say, the whole thing with climate change is about saving the planet, it's like the planet will be just fine, thank you very much. The whole issue about sustainability is we're trying to sustain us. We're trying to sustain this kind of civilization. And so I agree with you completely there. The difference, though, with your examples is with Easter Island and the Anasazi and the Mayans, that was local. There were other civilizations elsewhere. Again, my point about we have a global technological civilization, right? It's going to be very hard to build wind turbines if you're back to, you need a global civilization in some sense to have the resource extraction and movement, to have a truly high-tech, energy-intensive civilization. And so, that's what's vulnerable. It's you're not going to there's going to be no one else in another continent to help you out.
I agree with that, but if it sets us back a million years and we have something else that comes along, you got to take a global view to survivability, right?
Right. It could be the cockroach. Right. There's going to be another chance.
Anyway, it's not only humans which are vulnerable. Right. It's all mammals. So probably if we screw for us, then all mammals will be in danger. Birds even affected, they say. So insects in some way, but definitely some life forms will survive here, and they will advance.
One of the things in Brandon Carter's original argument, one of the reasons the way he's so good at taking one observation and building this enormous argument. And this is an interesting idea, is that he said, look, life started really early on the planet, but intelligence, we're almost at the end of our habitability. The Earth's we only have another maybe billion years of the Earth being habitable.
I think it's less, yeah.
Right. And so his point was there may not be time. There may not be time to reboot. And I'm not sure I agree with that, but I'm just saying that was his argument, that it took a long time to
There will be heat lovers, come on. They will adjust. Life is not only survivable, it's adaptable.
Right.
So, and on this 100 million years what we have to live on through heating planets, then there will be life which will love it.
Well, will it climb back up the ladder of intelligence and civilization? That's the open question. I agree. There's no way we're going to.
That's why I like to talk about great filters. There's lots of things that can get in the way for that to happen a second time, not to mention the first time at all. But again, we're talking about numbers that are so great that they will probably happen. That will probably succeed somewhere, maybe not twice in the same place. It's a lot like lightning striking you. Adam, can you comment a little bit on this concept of Anthropocene, that period? I guess we're entering this period now of the Earth's history where we're the ones that are responsible for changing the planet.
Right. So the things we've learned over the last, 50 years of studying Earth's history, it's all right. Earth has gone through many of these different epochs, and the amazing thing that I learned from this is that, Earth has been so many different planets, right? We think of it as this nice blue-green globe that's got continents, and, if you visited Earth, somewhat early, it would have been an ocean world, right? It took a while for the continents to build up, and if you visited the Earth at some points, it would have been a snowball world, almost entirely glaciated. So, Earth has gone through different epochs. Life has been not always, but almost from the beginning, life has been a pretty serious driver of the changes on the planet. And so the idea is after the last ice ages, we entered the Holocene, which, it's an interglacial period. It should have lasted about 10,000 years, and it's a period when the Earth is pretty moist and pretty warm, right? What has happened with our introduction, particularly with the Industrial Revolution, is that we are now the principal drivers of changes in the coupled Earth systems: atmosphere, oceans, ice, lithosphere, land, and biosphere. So human beings now have this enormous impact. And so now we're entering an era which is termed the Anthropocene, where human impacts, even if we die out, even if we could somehow extinct ourselves, those impacts are we were pushing the planet into a new regime. And it's, we are the ones who have driven it into this new regime. And we shouldn't be surprised at this, because the oxygen we're breathing, right? The only oxygen here is because life changed the atmosphere.
Exactly. There was a Bacteriocene before. Come on.
Right, exactly.
Now it's Anthropocene.
Right.
Bacteriocene, yes, they changed. It was method rich, then it became oxygen rich. They poisoned themselves, and new bacteria survive, and new life forms survive. So.
Amazing, the great oxidation event. It's amazing. Life just completely hijacks planets. It's the Gaia hypothesis on some level, whether or not you believe the full Gaia but biospheres change planets, and we are, as a advanced civilization, we're just another thing the biosphere is doing. We're another experiment that the Earth is running.
Yeah, there is a joke on that. The planet talks to another planet. It says, hey, I have life, it's like, I have life on me. And the planet says, oh, don't worry about us.
It's an infection, don't worry about it.
Yeah.
Well, do you guys have a sense? Okay, so the universe is 13.7 billion years old. And galaxies, when we look through the Hubble Space Telescope far away, we see these early galaxies that are very misshapen. They're very rough. They're smaller. They have they're still, the stars in them are very rough and very high energy. They don't live very long. Do you have a sense, any of you, about whether life existed in this early epoch, and I mean maybe between 1 and 3 billion years after the Big Bang, or was this something that we're looking? Is there kind of an Anthropocene for the universe? Like right now, there was a period, and Svetlana and Jeff can back me up on this, where there were a lot star formation was at its peak. Right, we've long since passed that, but is there something like that analogous to life?
That's quite interesting.
Yeah, no, it is an interesting idea. First of all, you can't have planets until you have metals, right? Which means you've got to have enough supernova.
Good point. You've got to have a lot of the building blocks of life.
Right.
Yeah, I think it's like it has to correlate with the number of planets in the universe. I mean,
exactly. Right. And so then you need, but that's pretty early. You get enough metals by
after first generation of
right. So I think first, second, third generation of massive stars, which only live 1 million years, right? I think we have to actually do the calculations, but I think you're already in decent shape to have.
Look, metal poor stars, 10 to minus 4, 10 to minus 5. This is like a second generation stars. So it takes like 3 generations of stars, like sun-like stars, let's say, to get into the point where we are now at this metadicity level. So
it's probably pretty quick that you have planets. Now, there's also if you have a lot of starbursts going on, then you have the possibility of wiping out life on the planets. We did some calculations. We did simulations of the galaxy, and we were trying to do the Fermi paradox. And we looked at least there we were looking at civilizations colonizing other worlds. And we included in those simulations the supernova explosions. And what we found is that, in the case where you actually have spacefaring civilizations, which is huge assumption, but in that case, it was very hard to really wipe out a large fraction of the life in the intelligent life in the galaxy. It would just fill in quickly. You'd have a region that would be a bubble that would be sterilized, and then pretty quickly you'd fill it in again. So, but that's spacefaring life. So I'm not sure how relevant that is. Okay.
All right, let me get let me ask Caravan if he's got any questions for us from anybody. Have you been reading the?
Yeah, there's a few. One of them by Damon Pasha asks, "What size are we in relationship to this advanced civilization we are looking for? Should we swap telescopes for microscopes, or must they only be defined in small, medium, large, extra large sizes?"
The larger the better, always.
For detection,
Well, you raise a good point in your paper, Adam, about the fact that, this is great to talk about. The practical use of it, though, is a little bit wanting, because if we find something, say, 20,000 light years away, just to send a message is going to be a 40,000 year proposition, right? I mean, at the speed of light. So this is... I guess we could be optimistic, but we can certainly be pessimistic about the fact that we may ever really be able to do anything about it.
That's a huge, interesting question, right? I mean, so the amazing thing about this moment in history is that in the next 10, 20, 30 years, we're going to actually have data about the question of life, right? The project that you guys are doing, trying to build telescopes, we have the capacity now to do the atmospheric characterization and begin to look for actual signatures of both biospheres and the possibility of technospheres as well. But once we find it, let's say we found it, that would be, the greatest scientific revolution ever. I'm not sure what we can, we can keep studying it, but if it was actually a technosphere, having a conversation is kind of there's only so much you can do with a conversation, because of the light delay. So, there's a certain way in which I'm not sure how, it's a very open question of what happens next in terms of, any kind of communication or anything.
Well, definitely. We're sending messages now anyway to nearby planets. As a humanity. So we just pick up these nearby systems and send them anyway. 45 years it takes only. And, well, we don't know. Maybe our grandchildren will get answer, That's possible. We don't know.
I think it would change, though. I think the discovery of just a biosphere would really fundamentally change our understanding of ourselves, right? That's what the work that I'm doing with the astrobiology of the Anthropocene, part of it is it's not just science, it's also philosophy. Even, I use the word mythology in the general sense of human beings have stories we tell ourselves about who we are and what we are. And we really have not absorbed the astrobiological revolution that's going on, right? That we are just... Excuse me?
You didn't absorb these astrobiology stories in our mythology?
Yeah, because it's new. So
there is genesis stories and cosmogenic stories.
Right,
yeah.
Right. And so now we have this new understanding, or this developing new understanding. So if we found, evidence for a life on another world, I think it would have a really big impact. It may be long term, but on how we view ourselves, how we view what we are on this planet.
Yeah. Hopefully we understand better that, or what shall we do here also?
Well, I think that's the point, is we see ourselves differently. The word I use is we think of ourselves as a one-time story, right? Mm-hmm. And that's why our reaction to climate change is so crazy. I don't think it's just about education, because I argue with a lot of people about climate change, and some of them are pretty educated. It's more the view that we think we think of ourselves as being the first time this has ever happened. So it's like almost this philosophical problem people have with understanding, like, oh yeah, like here's the way. It's not, is climate changing happening? It should be like, of course climate change is happening. You built a giant civilization. What did you expect? Right? And so we don't have that perspective because we think of ourselves as a one-time story.
Okay, anything else, Kevin?
Yeah, Cosmic Stardust asks, how many levels of habitability do you all think needs to be considered for intelligent life, i.e. planets, galactic, even considering galactic voids, etc.?
What was it, quite different levels of what?
Different levels of habitability.
Well, I think this kind of definition of habitability is also limiting. But I mean, we talk about this liquid water habitable zone. That entire planet can have that ocean. But we also realize that on Earth, and in time and in space, the places, different places on Earth are habitable and inhabitable, and that was varying and changing. So that kind of I think it's artificially created this kind of for simplicity,
right.
Just for us to easier to operate in that space with multidimensional space of parameters. We just created this kind of habitability concept, but it is enormously broad if we just allow this being beyond the frames what we created ourselves. So I think it's not like how many levels; it's a continuum.
Right.
It's and everything is possible, maybe.
It's interesting. That has consequences for what we do with detection, right? It wouldn't. I don't think it would change our number very much. The pessimism line, because it's pretty. I think that's pretty robust. But with detection, what do you do what if like most life forms on moons, on the oceans, the subsurface oceans?
Absolutely.
Yeah, in the moons, like because you can never see, it's under.
Yeah, we talk about like surface signatures, but what about undersurface? On Earth, we have this enormous undersurface biosphere, and we think that we can discover same on Mars and in Europa and somewhere else, and so this. So those we just completely exclude from that definition of habitability. So that is.
Yeah, right. I mean, I think it's worthwhile. It's deeply worthwhile considering both, from the scientific point of view, and then particularly the detection point of view. What do we do with these other possibilities as we broaden our definition?
So, Adam, let me just real quick. I got to get this in. Does your research and the numbers that you crunched with your statistics it leaves open the possibility then? I mean, I agree with Jeff. We do not occupy any special place in the universe. I'm not advocating that we do, but it's possible that we are right now the only young technological civilization in the Milky Way right now.
Possible.
Yeah, I think that's very possible. It might even be likely.
That's what I was going with that. So.
Yeah, I mean, again, that's hard to say, but I mean, I think. It's more than possible because again, everything depends on L. Everything depends on the lifetime,
and L depends on the number of miracles you have to go through. And
exactly.
No. Wait. L is independent.
Miracles are great filters to me. That's
but L is not part of those miracles. L is what happens once you get to a technological civilization. So L.
Also, you've already gone through the miracles to get there. And
but it could be not a miracle to wipe us out.
Miracles all the way down. You still have miracles down.
Yes. Could be positive miracles and negative miracles, so we can classify them.
That L, that's why I love to call it the final factor, bum, 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 bum. But that number really so much depends on, what.
It's 10. No, it's 42, of course. What am I saying?
42,
It's like, I think that, it's true that, like, if there is something like a singular, it may very well be that if you make it through, like, this bottleneck, that we become machines. That, like, I really think that's, a reasonable possibility that eventually...
Jeff, do you believe in the singularity? Do you think that's going to happen?
Well, let's put it this way. Suppose you were offered the chance to live forever. Would you take it? Suppose you were offered the chance not to be as sensitive as we are in our wet chemistry that maintains.
I might take that. I don't know about living forever.
All right. Suppose you were given the chance of communicating over the internet without having to use your lips or your mouth or your fingers. That you could plug a USB 15 into the back of your head and have instant access to the whole world. Would you take it? Yeah. Well, and every young person I know sits with their. I mean, the communication is now via how fast you can, how fast you can create ASCII characters. I think that the issue is the irresistibility that life has to propagating itself and to existing forever, and we are within. My son is doing a program in neuropsychology, and folks are talking about decoding individual neurons and being able to extract all the information that rests up here in your head and putting it someplace where it's not as susceptible to damage as it is in my body, which lives for a very finite period of time. There's a huge pressure to be able to now, I mean, we call it this sort of meld technology with biology, but what if that's just the natural sequence of evolution? What if it's not unnatural at all? What if
climate change would be less of an issue for us if we didn't have to worry about
No, that's exactly true.
Yes.
That is exactly true.
And science fiction has figured it out that humans become electromagnetic waves traveling with the speed of light all over the universe and learn anything they want to.
I saw that start.
Okay, I really want to get this question from Alexander Reinders in before we run out of time. He's asking, and this goes back to the initial thing you were saying about the Drake equation, Adam. He's asking, are there any specified or improved terms in the Drake equation? Now, let me put that back up again, because this you changed a lot of terms in here. And do you feel like your bottom version is a revised and better version?
It asks a different question. I mean, because it still is, we just grew. I mean, in some sense, we just put terms together, grouped them together, and messed with them. So I don't think it's a better version. It asks a different question. It allows you. What it does is it allows you to answer a specific kind of question that we didn't, because we didn't have that data. We didn't have the Kepler data, etc. You couldn't answer before. So it's about reformulating it with a specific question that you can answer. Like so much of science, there's lots of questions you want to answer, but which question can you answer? So what we were able to do to set that pessimism line by doing it this way. I think that the Drake equation will continue to serve as a guiding principle for our understanding. It was an act of simple genius in formulating it that way, and that's why it stayed for so long.
So the question that you're asking is not that how many there are, but more would they have existed at all?
Right. I mean, the question we're asking is how probable. What we're really saying is how unlikely is it that we are the only time it's ever happened? And what comes out of the pessimism line is that you got to be extraordinarily pessimistic to say that it hasn't happened before. And from that comes this enormous consequence. If it's happened before, then what we're going through now with climate change is also likely a story that has been played out. And so then what is the consequences of that story on average? So there's this whole sort of like...
How can you answer that? What are the consequences of the story on average?
You can model it. We know enough about planets now. That's the whole point of the work that we're doing. We know, at least for this civilizations at our level, right? I can't talk about an advanced civilization, but for a young civilization, you can model, because we know the laws of climate. We know about how climate responds to energy input. A civilization is just a mechanism for dumping waste heat, or other processes into it. And that's that paper that I sent around. We've just done the first simplified models of exactly that to see what are the possible classes of trajectory, for a planet and its high-tech civilization, right? And so imagine if I have really good models like that I sort of believe the physics of. I could run 20,000 of those and see how long they last and get a theoretical value for the final factor. Bum 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 bum.
Right, you're gonna do that every time. That's the soundtrack. Danny Schreiber, I just got to say real quick that you want to get the image that I just showed. There's a link in the description box to the press release at University of Rochester. It's in the press release, and you can look at it in better detail there. That's where I got it from. Is it okay if they download it, Adam? Is that okay?
Yeah, sure.
Okay, good. So it's it's good for that. So, okay, well, all right. I guess any more questions before I go, Kevin? We got one more minute.
I'm good to go. I haven't seen any new ones lately.
Okay, and so I just want to get to one on Andrew Planet has been on Facebook, and I want to thank you for commenting, Andrew. It's good to see you again. He's asking if technology ever got so advanced that it could think for itself and outthink humans, which I'm assuming would be a singularity type thing, wouldn't cognitively see itself as the next rung in the evolutionary ladder and seek to preserve what gave it its existence, rather than make us go extinct as if an apologetic bad attitude. If tech were ever that advanced, it would be well within its power to preserve us. So
we'll become pets.
I think that was in support of what Jeff was saying.
Yeah.
And so that's a good comment, Andrew. Thank you for making it. All right, folks. Well, Adam, this has been fun. Thank you for joining us. Any chance we can get you back?
Yeah.
Absolutely.
We have a lot more to talk about in this whole business of you've done a lot of great work also on in the area of climate change and thinking about this as well with respect to advanced civilization. So I'd love to have you back. Okay, well, good. So that is it for this week, guys. I want to thank on behalf of Dr. Svetlana Berdyugina and Dr. Jeff Kuhn and Kevin Lewis. I want to thank you and thank Dr. Adam Frank. He's a professor of physics and astronomy at the University of Rochester, New York. He's also a contributor to NPR. He's got a blog. Andrew or Adam, can we easily say where your blog is?
Yeah, if you just do NPR 13.7, The Age of the Universe, that's the name of the blog, 13.7 Cosmos and Culture.
Good.
So,
that's a great name. Awesome. Yeah, check it out, folks. It's good. I just found out about it like 20 minutes before the Hangout, so I'm going to go read it myself. So that's really great. So thank you very much, Adam, for joining us. Next week, we have – do you want to talk about it, Kevin, what we've got?
You go ahead, Tony.
Well, we have I have to pull it up because I was hoping next week.
Avi Loeb.
Thank you. Avi Loeb will be with us talking about Breakthrough Starshot and some of his works there, as well as he's going to be talking about his work with Breakthrough Starshot. He and the attempts for the Foundation to launch the first mission to Alpha Centauri within the next generation. So we will have him with us to talk next week. So I hope you guys will join us. I want to also mention, please let's continue the conversation. We can do that now. If you go to anchor.fm/Deep Astronomy, I have a station there where you can call in. And if you call in a question to that station, I will answer it, or I will get an expert to answer it for you if I don't know the answer. So let's continue the conversation and listen at anchor.fm/Deep Astronomy, and we hope you will participate. So, all right. Well, on behalf of everybody, I want to thank you all so much for watching. And as always, keep looking up.